Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. I'm going to be talking about graphing rational functions. So I've talked about the asymptotes, how to get all that in the previous videos, okay? If you've not reviewed my previous videos, I don't know what you're doing. Please, before you come to this video, make sure you've reviewed the previous videos in this series, especially how to find vertical asymptotes, horizontal asymptotes, and slant asymptotes, as well as X and Y intercepts. So if you're not sure, just go to the playlist, okay, and just search X and Y intercepts. Then the video comes, the video will come out. Then you just watch it. And if you're not sure about the how to find asymptotes as well, just click on vertical asymptotes. The video will come out as well. You watch it. It's the same thing for both horizontal and the slant. All right. Okay. So before we start, if you've not subscribed, liked, or shared this video, I don't know what you're waiting for. Please do so, and don't forget to click on the notification bell. All right, so that when I post new videos, you'll be the first person to know. All right, just to remind ourselves what to things to review before you come into this video. Please make sure you review this. Okay. Make sure you review how to find the X and Y intercept. It's important that you review how to find the X and Y intercept. Then when you're done with that, you need to also review how to find the vertical, the horizontal, and slant asymptotes, okay? So make sure you review how to do solve all this. So I talked about this in the videos, and I also highlighted and listed the rules, and also review how to sketch. So remember, I told you that when you're sketching graphs does not actually mean you're plotting all the values, is that you're just trying to get a general shape or idea of the graph. Okay. All right. So let me remind you as well, because we're talking about rational functions. So a quick reminder of the general form. I believe if you've been following the videos from the beginning, now you should know the general form of a rational function. And it's going to be px divided by what? Qx plus d, or you can have f of x. Remember, I said in a rational function, it's the only case where you have the numerator as a constant, okay? And it also count as a rational function. Also, you can have a numerator as a constant. I also have a linear function, and still it also counts as a rational function, okay? All right. And also for this to be correct, I told you as well that qx must not be equal to 0. All right. And or bx plus c must not be equal to what? 0. So we talked about all this in the previous video. So I'm not going to talk about that. I'm going to go straight in. How do we graph rational functions? All right. There are 8 steps or rules on how to do that. Okay. There are 8 steps or rules on how to graph rational function. Okay. So I'm going to write them all down first so that I will now pick some example and we're going to graph it together. All right. All right. So the first one is that you have to first write the rational function in the general form. So you have to write the rational function in the general form. Okay. So remember the general form, the p of x divided by q of x plus d, and a over bx plus c plus d. So you have to write this in the general form. Then when you're done with that, the next step you have to do then is that you have to factor the numerator and the denominator, okay? And if possible, you have to check if anything can be canceled out, okay? So basically what we are trying to do is that we're trying to see if there is a hole in the rational function. Okay, so please go back. I also have a video on how to plot, how to find holes of a rational function. And if there is a hole in the rational function, you have to take note of that coordinate, and also you have to plot that hole when you're sketching the graph, okay? So basically what I said is that you have to factor the numerator and denominator, okay? So you have to factor it. And if possible, all right, check for common factors. Okay, so if anything can be canceled out. So basically what I'm referring to is that I'm referring to common factors, okay? So basically you're checking for common factors. And the reason why you're checking for common factors to see if there is whole. And if there is whole, you have to take note of the coordinate and you have to plot the whole, if any. So if there is a coordinate for the whole, maybe the coordinate for the whole was 3 and 5, you have to keep it down. So when you're drawing the line, you have to then plot that whole on the line. So when you've done that, okay, you've written it in standard form, you found out if there's a whole or not, then the next thing is that you have to then find the x-intercept. I have a video on how finding x-intercept, and it's in the playlist, so you can go back and look at that. So, but remember I told you for at x-intercept, y is equal to what? 0. So at x-intercept, y is equal to 0. So that means you're gonna plot in y equals to 0 and solve, okay? Now, but if, for instance, there was a hole in step 2, now what you're gonna use to find the x and y intercept, you're gonna use the simplified fraction, okay? Okay, so you're gonna use the simplified fraction to solve. So please, when I was talking about the holes, I talked about the common factors and the simplified fraction. So please go back to that video and see what I mean by the common factors and simplified. So, but if there is a hole in step 2, you have to use the simplified fraction. Okay, so you use the simplified fraction. If there is a hole in step 3, there's a hole in step 2. I beg your pardon. Then when you've done that, you found the x-intercept. The next thing you have to find is the y-intercept. So remember at y-intercept, x is equal to 0. So you're gonna have x is equal to 0. So I have a video on how to find the x-intercept and how to find the y-intercept. So please go back and have a look at it. Now, after you found the x-intercept, you found the y-intercept, the next thing you have to do is that you have to identify, okay? You have to identify the vertical asymptotes, okay? So I already have a video on this already. I've already explained how do you find vertical asymptotes. So the next thing you have to do is to go back and see how do you find the vertical asymptotes. Then after you found the vertical asymptote, the next thing you have to find, your guess is as good as mine, you have to identify and see if there are any horizontal or slant asymptotes. Okay, so you have to see if there's a horizontal or slant asymptote. All right, so the first thing you do, you find the vertical asymptote. The second thing you then do, you then find the horizontal slant asymptote. All right, so that's step 6. Now, when you've found, written it in general form, you've found the common factors to see if there's a hole, and you take note of the hole, you find the x-intercept, you find the y-intercept, you find the vertical asymptote and the horizontal asymptote. Now, step 7, it gets a little bit interesting here. So because we're trying to sketch, we're gonna just get some random points as well. So basically you're gonna plot or add some additional points to be able to see the general shape of the graph, okay? Because it's a rational function, and you see what I'm talking about, so for you to have a general shape of the graph, so you have to plot enough additional points, all right? So you're gonna just have some random points, some random additional points. okay, to be able to see what the graph is doing. Okay, so you're going to plot additional points to be able to see. So usually what I do is that I draw a table of 2 columns, X and Y. So I try to draw 2 columns, X and Y. Then I place the X-intercept, the vertical, horizontal asymptotes on the table. Then I take some random numbers in the X columns and try as much as possible to find the corresponding Y values. Then I plot all the points. Is that okay? So I'm going to write it down. So generally, it can help you. Usually, I find it more helpful for me because I try to make some right guesses. Okay. So what I do is I draw a table. So I draw a table of 2 columns. X and Y. Okay. And when I've drawn the table, then I place the X-intercept because I've calculated it already on the table. Okay. I'm going to pick an example to explain this, okay? Then also I'm going to put the vertical and horizontal asymptote on the table. Okay? Then after I'm done with that, then the table I'm going to take some random numbers and put it in the X column on either side of each of the X-intercept, all right? So I'm going to I'll take some random numbers. So I'll take some random numbers in the X column, all right? Don't worry, I'm going to pick an example, okay? And we'll solve it together on either side of each of the X-intercepts. Okay? And also, I'll do the same thing for the Y-intercepts and vertical asymptotes. So when I've done that, then I will then find the corresponding values of Y by substituting it into the original function, okay? Then I will then find the corresponding value. So we find the corresponding Y values by substituting each of them in function. Okay. Then after we're done with that, I will then plot all the points, okay, from the table and try to join them. So because I took some random values, so it's more of like a right guessing, okay, I took some random values, then you will see that the shape, when I'm plotting the points, you will see that the shape already is already coming out already. So you then plot all the points. From the table and join them. Okay, when you plot them, you then join them, or you join the curve. So you join them into curves. Join them giving a curve. without touching the asymptote. So remember, the curve can never, okay, touch the asymptotes. Then when you're done with that, step 8, you then sketch the graph. Good. Oh, it's a long 8 steps, right? But it's very simple. When you know what to do, this will take you less than. So usually I write all the steps so that when we're solving, it will be easier for you to understand. Is that okay? All right. Let's pick an example, okay, to explain this. So let's assume we have this rational function and we're told to graph. So let's assume we are told, number 1, we're told graph, okay, the rational function. Okay, we're having y is equal to 2x plus 5 divided by x minus 1. And we're told to graph this, for example. All right. So this is a rational function because it's a ratio of polynomials. And you can see as well here in this case, because a rational function is a form of p of x divided by q of x plus d, right? That's a rational function. And you can see in this case that the d in this example is 0, okay? So it's fine. So let's go. Step 1, write the rational function in the general term. So let's go. The first step, we have to write it in the general term. So it's going to be y is equal to 2x plus 5 over x minus 1 plus 0, okay? Because d is 0, but there's no need for doing that, okay? The next part is factor the numerator and denominator if possible to check anything, to check if anything can be canceled out. So we're basically checking for wholes using common factors. So let's go. So if you look at this example, for instance, we can't factor anything here, so it's not possible. So we can't factor, so that means there's no common factor. So not possible, hence no wholes, right? So that means this particular function has no wholes. So we're going to move up to the next one. All right, good. So step 3. What is step 3? Step 3 now said that we have to then find the x-intercept by using y is equal to 0. So now we can use a simplified fraction in this case because there are no wholes, but now we're going to find the x-intercept for this. All right, so to find the x-intercept, so we know that at x-intercept, y is equal to what? 0, okay? So what you're going to do, so we're going to have y is equal to 2x plus 5 over x minus 1, whereas x-intercept, y is equal to 0, so it'll be 0 will be equal to 2x plus 5 divided by x minus 1. All right? So what's the next step? In order to remove this fraction, I'm going to multiply both sides by x minus 1. I'm going to multiply this also by x minus 1. So this is going to cancel this out. X minus 1 multiplied by 0, that will still give me what? 0 will be equal to 2x plus 5. Okay? Then we're having this here. Then to find x, I'm going to take 5 to the other side, or I'm going to take 2x to the other side. So anyhow you want to do it. So, and that will give me now the next part is going to give me, if you take 2x to the other side, you're going to give you minus 2x is equal to 5. Are you seeing it? Then you now divide both sides by minus 2. So x is going to give us minus 5 over 2. So the x-intercept, we can now say when x is minus 5 over 2, y is what? 0. So that is the x-intercept for that. Okay? Or you can write it again as minus 5 over 2 is the same thing as saying minus 2.5. So if you want, you can also write this as minus 2.5 comma 0, if this will make you happy. All right? So you can write it anyway. So you can write it as minus 5 over 2, comma 0, or you can write it as minus 2.5, comma 0. All right. So that is step 3. Let's go to step 4. Step 4. All right. We have to then find the y-intercept. So find the y-intercept. So we know at y-intercept, x is equal to what? 0. All right, so we already have a function. We have a function of y is equal to 2x plus 5 divided by x minus 1. Y is equal to 2x plus 5 divided by x minus 1. So now at y-intercept, x is equal to 0. So that means y will be equal to 2 into bracket 0 plus 5 divided by 0 minus 1. Okay? So y will be equal to, so if you press this in your calculator, this is 0 plus 5, that'll be 5. 5 divided by minus 1 will give you minus 5. So y is equal to minus 5. So the x-intercept, sorry, the y-intercept, when x is 0, y is what? Minus 5. So this is the what? The y-intercept, okay? And this here was the x-intercept. So we've gotten the x-intercept, okay? We found out that there is no holes, okay? And now we found the y-intercept. All right. That is that for that. So we're gonna go to step 5. Step 5, we need to find the vertical asymptote. So step 5, we're going to find the vertical asymptote. All right, so let's find the, let's go to step 5 for the vertical asymptote, all right? So remember, to find the vertical asymptote, the denominator is equal to 0. Do you remember? So if you've not watched my video on how to find vertical asymptote, please go back and have a look at it. So for vertical asymptote, all right, we talked about this earlier. Find the vertical asymptote, the denominator is equal to 0. Okay, so we have, so let's go back. What is the denominator? X minus 1. So x minus 1 equal to 0. So therefore, x will be equal to what? 1. So we found the vertical what? Asymptote for this. The next thing, step 6. After finding the vertical asymptote, the next thing we need to find is the step 6. We need to identify the horizontal asymptote or slant. So basically, in this case here, we can have slant, but we're going to have horizontal because the degree of the numerator is equal to the degree of the denominator. All right. So you can see the degree of the numerator is 1. Degree of the denominator is 1. So n is equal to d. So we talked about this as well. So for horizontal asymptote, okay, we can see that the degree of numerator is equal to the degree of denominator. So therefore, because the degree of n is equal to the degree of numerator is equal to the degree of denominator, then it's going to be the ratio of the leading coefficient. So that means the coefficient of the numerator divided by the coefficient of the denominator is going to give me the horizontal asymptote. So it's going to give me the coefficient here is 2 divided by the coefficient of this is 1. So the horizontal asymptote is equal to 2. So therefore, horizontal asymptote, or you can say y, is equal to what? 2. All right? So we talked about this already. Found that already. Now the next one, let's go to the next step, which is step 7. Okay. Now step 7, okay, where we're plotting the additional point. So we're going to plot additional point to be able to see what the graph is doing, okay? All right, so it said draw the table of 2 columns, x and y, and place the x-intercept, vertical, and horizontal asymptotes on the table. So let's draw the table first. We're going to have a table like this. We have x and y. Okay, so we're going to start with the x-intercept. So we're told the x-intercept is minus 2.5 and 0. Okay, so x-intercept is minus 2.5. The x-intercept, let me take this, you'll have minus 2.5 and y is 0. Okay, then the next one is that we have the y-intercept is 0 and minus 5. Okay, so we have 0, okay, and minus 5. So x is 0, y is minus 5. So I'm going to label this just for it to be clear for those writing. So this is the x-intercept. All right, I've done that. And this is the y what? Intercept. Okay. Then what the next thing I was told to write as well? We're meant to write the vertical and the horizontal what? Asymptote. So the vertical asymptote, so the vertical asymptote we have it to be 1, okay? Then the horizontal asymptote. So remember the vertical asymptote is the same thing as what? The x value, okay? Then the horizontal asymptote is the same thing as the y. Y is 2, so y is 2. And we have the horizontal asymptote. Then, yep, we've done that. So the next thing we're told to do, we can take some random numbers in the x column on either side of the value. So let's get some random numbers now. So we have minus 2.5. So maybe I can put minus 6 here. Okay, just for fun, I can put minus 1 here. Okay, then I can also add maybe make more space, right? So I can also add maybe 2, maybe another one, 3. I can add maybe 6, maybe 8, and maybe 15, something like this. That is it. So I just added random numbers. So I added minus 6, minus 1, 2, 3. You can add any numbers you want. Now, what do you do next? The next thing is that after, you have to find the corresponding y values by substituting it into the function. So let's go. Let's substitute it into the function. So we already know the function is what? Y is equal to 2x plus 5 divided by x minus 1. So we have it as y is equal to 2x plus 5 divided by x minus 1. All right. So we're going to find the x values for each of them. So anywhere you see x, you put minus 6. It's going to give us 2 into bracket minus 6 plus 5 divided by minus 6. That's your x, right? Minus 1. And when you solve this, your answer is going to give you 1. Okay? Same thing. We put minus 1 into the equation here. So it's going to give us 2 into bracket minus 1 plus 5 divided by minus 1 minus 1. And that will give you what? Minus 1.5. So we already have the first value here. So now to differentiate it, to make it easier. So the y value we have here is 1. The y value we have here is 0. The y value we have here is minus 1.5. The y value we have here is minus 5. We have the y value to be the vertical asymptote, so we take note of that. And the y value we have here is 2. This is the horizontal asymptote. You take note of that. Then repeat the same thing as well for the other values. So you can add as many random values you want, but I'm going to just pick this few. So remember, the essence of the random values is for you to have an idea of the shape of the graph. So it does not really matter. I just pick few ones. So usually what I do, I pick some negatives and I pick some positives. That will be enough for you to know the shape. So the same thing, we're going to have 2 into bracket 2 plus 5 divided by 2 minus 1. And when you solve this, your answer will give you 9. Same thing, 3 into bracket 2 plus 5 divided by, oh, sorry, I think I messed it up here. So we're having 2 into bracket 3 plus 5 divided by 3 minus 1. And when you solve this, your answer will be 5.5. You do the same thing here. 2 into bracket 6 plus 5 divided by 6 minus 1. And when you solve that, the answer should be what? 3.4. You have 2 into bracket 8 plus 5, and you have 8 minus 1. And when you solve it, the answer should be 3. You have 2 into bracket 15 plus 5 divided by 15 minus 1. And the answer should give you what? 2.5. So we can now highlight the y values, okay? So you won't get confused for each of the x values, okay? So these are the what? The y values for this. All right, then we're done with that. Then step 8, we have to now sketch the graph. Step 8, we then have to then what? Sketch. So we're gonna step 8. Okay, change this back to blue. So we have step 8. We want to now what? Sketch this graph. So remember, sketching the graph is that we're gonna just use those points here, okay, to sketch the graph, all right? All right, so let's sketch this graph. So we're going to have something like this. So let's make the have the x and we have the y, okay? So to make it interesting, we're gonna have maybe to 12. So we're gonna have 2, 4, 6, 8, 10, 12, 14. The maximum x we had was 15, right? So we're gonna have 14 and 16. Then we're gonna have -2, -4, -6, -8, -10, let's say -12. So this is for the x-axis, okay? Now for the y-axis, we're gonna do the same thing to make it interesting. The maximum y value we had was about 9, and the lowest was about -5. So 2, 4 can also work here. So we can say 2, 4, 6, 8, 10. So you can add one more, 12. Then we can have -2, -4, -6, -8. Okay, we have -8. Then we can add one more, -10, to make it interesting. Okay, so let's go. Let's start. So what I always advise students that the first thing you do, try and plot the vertical and the horizontal asymptote, okay? The horizontal asymptote is at what? At 2. So let's go. The horizontal asymptote is at 2. So this is going to be the horizontal asymptote. So that means the curve will come close to this line if it's coming close, but it's not going to touch it. So the horizontal asymptote is going to be at 2. Then what is the vertical asymptote? The vertical asymptote we had was 1. So we're going to go back. So 1 is somewhere here. Okay. So this is going to be the vertical asymptote for this. All right. And that is the vertical asymptote. All right, good. So the vertical asymptote was at 1. So this is where 1 is, okay? All right, good. So let's start, let's get cracking then. So we can then start by plotting the graph. The first one is at -6. X is -6, Y is 1. So let's plot the graph for this. I'm gonna use a black pen. So X is -6, Y is 1. So let's say somewhere around here, okay? Or basically, to make it a little bit more interesting, you can also plot the x-intercepts, okay? Plot the x-intercept and also plot the y-intercept, okay? So we know that the y-intercept is at -5. So let's plot the y-intercept. This is -5 here. Are you seeing it? Oh, sorry, that can be -5. That's -3, so -5 should be somewhere here, right? And the x-intercept is -2.5, okay? So let's go back. So if this is -3, so -2.5, let's say is -2.5 is here. So we've plotted the x-intercept, the y-intercept. Okay, so we can go back and plot each of them now. So the first one, -6 and 1. I've plotted -6 and 1. Okay, we've plotted this already. So we're going to jump to the next one. The next one is 2 and 9. So x, oh, sorry, I think I've jumped one here. -1 and -1.5. So x is -1 and y is -1.5. So x is -1 and y is -1.5. So if this is -1, okay, so -1.5, let's say it should be somewhere around here. Okay, somewhere there. Okay, so it's sketch, so it's not gonna be actually perfect, but you get the idea, right? Then the next one is plotted that 2 and 9, x is 2, y is 9, so somewhere around here. Okay. Then the next one is we have 3 and 5.5. So x is 3, so 3 is here, and 5.5. So if this is 5, let's say 5.5, somewhere around here. Then the next one is we have 6 and 3.4. So x is 6, y is 3.4. So if this is 3, so 3.4 slightly higher, okay? Then x is 8, y is 3. So x is 8, y is 3. So if that's 3.4, somewhere here. Then we also have x is 15, y is 2.5. So 15, y is 2.5, somewhere around somewhere here. So, and that is it. So when you draw the line, you can see that the shape of the line, it has to be a smooth, continuous curve, okay? So it has to be something like this, all the way close. Can you see? It's very close, but it will never, ever touch the asymptotes, okay? So it's going to be so close and be going down, but it will never touch either the horizontal or the vertical. The same thing, you can see in this case, it's going to be coming very close from infinity up to this point, okay? But it's never going to touch, all right? So it's going to touch at a point in infinity. Then you're going to draw this closely. It has to be just a smooth curve, okay? So it's going to be like this, a smooth curve like this, smooth curve like this. And it's going to be very, very all the way, but it's never going to touch the x-intercept or the y-intercept, okay? And that will be the curve for this, the shape of for this graph. All right, and that is how to sketch it. Okay, so let's pick one more example for this. So what I can advise, you can just try to, I'm going to write the example. You can pause the video, try and see if you can solve it, and come back and see if you have the same shape that I did. All right, so let's pick an example here. So let's assume we are told to graph this rational function. So example 2, we're told to graph the rational function below. Okay, so let's assume the rational function we had was y is equal to x squared plus 5x plus 6 divided by x squared plus x minus 2. All right, so let's assume this is a rational function. So you can press pause and see if you can grab this, and then you can come back and see if we get the same answer together. All right, let's go. Let's start with the first step, step 1. Okay, so step 1 is that we have to write this as a what? Rational function in the general form. So it's already written that because we already know that the general form for this is P of x divided by Q of x plus D, all right? So you have to be the ratio of two polynomials, all right? And you can see in this case, we're having quadratic equation and quadratic equation. So this is a rational function and the D here is 0. So basically it was written already in a rational function general form for you. So you just write it down. X squared plus x minus 2. Now, the second step is that we then have to factor the numerator and denominator. If possible, check if anything can cancel out. So basically, we're finding for wholes here, all right? So let's see if we can find any wholes here. So step 2, we are having y is equal to x squared plus 5x plus 6 divided by x squared plus x minus 2. Now let's factorize this. So can we factorize this? I've shown you how to factorize quadratic equation. There are several methods, difference of 2 square. We talked about use of trinomials when a is equal to 1, trinomials when a is not equal to 1. We use common factors method. We use quadratic equation as well. And I've talked about all these as well. So please go back and have a look at the videos and make sure you understood it. So I'm going to use trinomials when a is equal to 1 here. All right, so you can use any other method, any other relevant method, and you should get the same thing. So when you factorize, we look for two numbers that you multiply, that will give you 6, and you add, that will give you 5. And the two numbers is going to be x plus 3 and x plus 2, okay? Same thing as well. You look for two numbers that you multiply, that will give you minus 2, and when you add, that will give you 1. And that will become x plus 2, and you have x minus 1. So in this example now, you can see that we have a common factor here, which is x plus 2, and they will cancel out, okay? And this will now give you the simplified fraction. So the simplified fraction here, in this case, is going to be what? X plus 3 divided by x minus 1. And we have the common factors. So the common factors that we striked out in this example as well is x plus 2. But also, I told you in the video what we're talking about wholes, that in order to find the whole, you use the common factor. So the common factor we had here was x plus 2, and you equate it to be equal to 0 to get a whole. So to get a whole now, what you do, x plus 2 must be equal to 0. So therefore, x will be equal to minus 2, all right? But for a whole has both the x coordinate and the y coordinate. So you have to then substitute this x into the simplified fraction to get a value for y. So therefore, the y is going to be minus 2 plus 3 divided by minus 2 minus 1, and that will give you minus 1 over 3. So therefore, in this equation, the whole is going to be at minus 2 and minus 1 over 3, all right? So this is what you have here. So that's why before I started solving this, I had to start with finding the wholes, okay? I have to start with finding the wholes because it's important to, when sketching, to also identify any possible holes in your sketch. So now we found the hole, so we can go to step 3. So now let's go to step 3. Now in this case, in step 3, we have a hole, so it will not affect what we did. So in step 3, we're meant to find the x-intercept, but we're going to use the simplified fraction instead. That makes sense? So you're not going to use the initial rational function, or no, you're going to use the simplified fraction here. So let's go back. So we're going to have at x-intercept, we're looking for x-intercept. So at x-intercept, y is equal to 0. Okay, so now we're going to use a simplified fraction, which is x plus 3 divided by x minus 1. So we have y is equal to x plus 3 divided by x minus 1. So you can see, because we have a whole, that's why we're using this simplified fraction. Now, but if there was no whole, we could have used the original function. Is that okay? But if there is a hole, you have to use the simplified fraction instead, okay? You will get the same thing most times, okay? In most cases, you will get the same thing. But in some more technical questions, it might end up having some wrong answers. So it is way better to use the simplified fraction when doing this. All right, so let's go. So at x-intercept, y is equal to 0. So this will give you 0 will be equal to x plus 3 divided by x minus 1. In order to remove this x minus 1, we multiply both sides by x minus 1. We multiply both sides by x minus 1. So this will cancel this. X minus 1 times 0 will still give you 0, will be equal to x plus 3. So you take 3 to the other side. So therefore, x will be equal to minus what? 3. Okay? So therefore, y will be equal to 0. So the x-intercept, y is equal to 0, and x is going to be equal to what? Minus 3. So we found the x-intercept for this. Okay? So y is equal to 0 and x equal to minus 3. All right, so let's go to the next one, step 4. So we found the x-intercept. What is step 4? I believe y-intercept. So let's just check. Yes, we have to then find the y-intercept. So the same thing, you have to use the simplified fraction as well. So the y-intercept, so at y-intercept, okay, at y-intercept, x is equal to 0, okay? So you use the simplified fraction instead of the original. Is that okay? So now x equals x plus y equals to 3, okay? But x is equal to 0 in this case. So we're gonna have y will be equal to 0 plus 3 divided by 0 minus 1, okay? So which will give you minus 3. So y is minus 3. So that means when x is 0, y is what? Minus 3. And we found the y what? Intercept. Are you seeing how easy it is? Then step 5, okay? Step 5, we need to then identify the vertical asymptote. So remember, to find the vertical asymptote, you need to equate the denominator to be equal to 0, okay? So step 5, we need to then identify the vertical asymptote. Or let me write this in the new page. Okay, step 5. Okay, so we're looking for the vertical asymptote. So remember, when we talk about vertical asymptote, you equate the 0 equal the denominator to be equal to 0. The vertical asymptote, the denominator is equal to 0, okay? Okay, so as usual, you're going to use a simplified fraction, okay? So the denominator of the simplified fraction, x minus 1 is equal to 0. So that, therefore, we're going to have x minus 1 is equal to 0. So therefore, x is going to be what? Equal to 1. So this is the vertical asymptote, okay? Step 6, we then have to find the horizontal asymptote, which I believe, just to be sure, step 6, we have to identify the horizontal or slant. So because if you look at this function, we are having the function, they have equal degrees. So you're not expecting, or you're not expected to have any slant asymptote here. So we should be looking at horizontal asymptote. So, so to find the horizontal asymptote here, we'll find the horizontal asymptote here. So we know that the degree of the numerator is equal to the degree of the denominator. So in the simplified fraction, you can see degree of the numerator here is 1. Degree of the denominator here is 1. So that means we can see the numerator is equal to the denominator. Okay. So what do you then do? So to find the horizontal asymptote, what do you do? It will be the coefficient of the numerator divided by the coefficient of the denominator of the leading, sorry, the coefficient of the leading numerator divided by the quotient of the leading denominator. So if you look at it, the leading denominator here, so this is 1 and 1, okay? Or if you want to use the simplified fraction, this is 1 here, this is 1 here. So the number in front here is 1. The number for the denominator here is 1. So it's going to be 1 divided by 1. And the answer is going to be 1. So, and therefore, the horizontal asymptote, which is the same thing as y, will be equal to what? 1. All right, so we've gotten that. So now the next part now is that we then have to go to step 7. Step 7 is that we then have to plot additional points to be able to see what the graph is doing. So we have to then what? Draw a table. All right, so let's draw the table now. So we have step 7. Okay, let me write it there. Step 7. Okay, so we have x, and we're gonna have, okay, we're gonna have y. All right, so let's go. So we're told the first thing to do is to draw a table and put the x-intercept and put the vertical and horizontal asymptote, right? So let's go. Let's put it down. So the first thing we have, what was our x-intercept? Our x-intercept is -3. So x is -3, y is 0. So x is -3. So let's just put -3 here. And y is 0. So this is our x-intercept. Then we're going to put the y-intercepts, okay? So the y-intercepts, y is -3, x is 0. So y is -3, okay? Y is -3, x is 0. Sorry, x is 0. So this is the y-intercept. All right, good. Then the next thing to put, we're told to put the horizontal and the vertical and horizontal asymptote. So let's go. And what is the vertical and horizontal? The horizontal, x is equal to 1. Sorry, the horizontal, y is equal to 1, and the vertical, x is equal to 1. So let's go. The vertical x is equal to 1. So let's put that there. So x is 1, and this is the vertical asymptote, okay? Then the next one is the horizontal asymptote. Y is 1, okay? So y is 1 for this, so let's see. Yep, so the horizontal asymptote y is 1. Okay, so moving forward, so we have the vertical asymptote to be 1, and we have the horizontal asymptote as well to be 1. So I'm going to just write it here to make it easier. Okay, so we have the horizontal asymptote as well to be 1. So y is equal to 1, right? Okay, so like I said, we're gonna just put in some random values now in between just to give us an idea of what the shape should look like, okay? So these are the values we calculated, so I can just put them in asterisks so that it will be easier for us to understand. So I can just put maybe -5, -4 here. Maybe I can just add maybe -2, okay? You can also add -1 if you want to. Then maybe you can just add maybe 2 here, maybe 3, maybe 5, or you can add as much as you want, okay? So you can add as much as you want into the equation. All right, so like I said, because we had a whole, so we'll be using the simplified fraction throughout the calculation, right? And the simplified fraction we had was x plus 3 divided by x minus 1. So I'm going to just write it here, y is equal to x plus 3 divided by x minus 1. All right, let's go. So the same thing to get the y value. So it's going to be x is -5 plus 3 divided by -5 minus 1. And when you press your calculator, it will give you 0.33. Same thing. you put -4 plus 3 divided by -4 minus 1. And when you press your calculator, it should give you 0.2. Okay. Then if you put -2, the same thing, we have -2 plus 3 divided by -2 minus 1. When you press your calculator, it's going to give you -0.33. Okay. And 2, the same thing. When you press it, put it there, so it's going to become 2 plus 3 divided by 2 minus 1. And when you press your calculator, it's going to become 5. Then the next one is going to become 3 plus 3 divided by 3 minus 1. So that'll be 6. 6 divided by 2, it will give you 3. Okay. You can also have another one. Let's say we have 5 plus 3 divided by 5 minus 1. So that will give you 8 divided by 4. That will give you 2. So you can add as much as you want, okay? You can keep on adding as much as you want. Then step 8 now, where's where we now plot the graph, okay? Step 8, so we're going to sketch the graph for this, all right? So let's get cracking. So I'm going to draw the graph. So we're going to have okay, so we're going to have this here. So this, come on, right, something like this. A little bit straighter now. Then we have something like this. Good. Then we can have this to be 1. So the x, so the maximum value for x we have is from -5 to 5. So 1, 2, 3 can do. So we can have 1, 2, 3, 4, 5, 6. Okay, that's for the x. And we can then have -1, -2, -3, -4, -5, and we can have -6. Okay. Then for the y, the maximum we had was, I think, 5. And the minimum we had was around around 0. Minus 0. Yeah, I think we had -3. I think that's the lowest we have here. I don't think we have anyone. We have -3 here. Okay, for the y, okay. So, but for the x, we have from -5 to that. For the y, we have between -3. I think that is the lowest, but it's -0.33 that is this. So it's from -3 and up to 5. So we can also do 1, 2, 3 as well. So we can say this is 1, this is 2, this is 3, this is 4, this is 5, and that is 6, okay? And we can have -1, we can have -2, we can have -3, -4, -5, okay? And we can have -6, all right? So I think I can make this one a bit, okay? Okay, so I can put this here, 6, okay? So this is the y. So it's a sketch, okay? Just to give us a rough idea of what to do. So like we did in the last example, so what I'm going to do, I'm going to first sketch the main points, okay? I'm going to sketch the ones we calculated first. So we had the x-intercept. We have x is -3, y is 0. So let's sketch that first. So -3 and 0 somewhere here, okay? -3 and 0. The next one we can sketch as well. We can sketch the y-intercept, which is 0 and -3. So we are expecting a 0 and -3 somewhere here, okay? So 0 and -3 somewhere here, okay? Then we can sketch another one, the vertical asymptote. So we found that the vertical asymptotes, so we can draw the vertical asymptote. We found it to be 1. So vertical is 1. So this is it here. it has to cross, the vertical is crossing here at 1, okay? Let me do a better job than that, okay? So we have this, so this is 1, so let's drag it maybe like this will look better, okay? So this is the vertical asymptote for this graph. Okay, so this is the vertical asymptote. Then the next one is we have the horizontal asymptote as well. It's at 1 as well. So the horizontal asymptote here is 1 as well. So we draw the horizontal asymptote for this. Okay, the horizontal asymptote for this is 1. All right, so now we have done all the points we drew, so we can add the random points into the graph now to make it look better. So we have -5 and 0.33. So x is -5 and y is 0.33, so -5. And let's say this is 0.5, 0.33 somewhere. Let's put it somewhere here, okay? Then the next one, we have x is -4, 0.2, -4, let's say 0.2 is somewhere here. Then the next one we had is, so -5, we've done this too. We have x is -2, and y is -0. -2 and -0.33. So yes, I forgot to do something. Now in this example, we have a hole, right? Where was the hole? We forgot to plot the hole. Where is the hole for this question? The hole is at what point? We have it as O. Thank God. So this is it here. So we have a hole at -2 and -0.33. So that means this point we have here, this point we have here is a hole. So that means technically there is no point here. It's going to be a hole. So at -2 and 0.33, -2 and -0.33 is going to be a hole. So let's say this is the point here. So we're going to have a hole here. So this is where the hole is. All right. Good. Now, thank God. Thank God I did this. So we have a hole. It almost skipped me. All right. So you can also put another value here. You can put -1 and you can plot the point and you still get the same thing. Now the next one we have 2 and 5. X is 2, y is 5. All right. So let's go. X is 2, y is 5. Somewhere here. The next one we're gonna have is x is 3, y is 3. X is 3, y is 3, somewhere here. The next one, we're going to have x is 5, y is 2. X is 5, y is 2. All right, so you already got the shape already. So that means for this graph now, we can draw it. It's going to look like this. So if you draw this, okay, straight, it's going to keep going closer, but it will never touch. This is going to same thing. It's going to be going closer, but it's never touch at a point in infinity. So the same thing with this as well. You're going to draw this. Now it's a hole. I mean, the point is not, it's a hole. It seems to be there, but it's not there. Then it's going to go like this. Are you seeing it? Very close to the, it's going to go, sorry. So it's going to go very close, but it's not going to touch it. And it's going to go very close as well, but it's not going to touch it as well. So it'll be very, very close. And that is that. And that will be the graph for this particular question. All right. So you can also try to use, so the key thing as well is that I want you to remember is that there is a hole here. Okay. So there's a hole here. So this is the hole in the graph, all right? So it looks as if there is a point there, but actually there isn't, all right? And that is how you graph rational functions, okay? That is that for that. So the next topic I'll be going to is how do you graph exponential function? That will be the last one in this series, okay? And please don't forget, okay, when you're doing this, you have to remind yourself of the 7 or 8 rules. The first thing, you have to write the rational function in a general form. You factor the numerator and the denominator to see if there is a hole, and take note of the hole so that you can plot it when sketching. Then you find the x-intercept, you find the y-intercept, you identify the vertical asymptote, you identify the horizontal asymptote or slant asymptote. I have a video series on each of this, horizontal, vertical, and the rest of it. So please go back and have a look. Then you now plot some extra points so that you can give you the shape of the graph, just random points, okay? And after you're done, you then sketch the graph, and that will bring it to the end. Okay, so that is it for that. So I will see you in the next video. That's exponential, how to sketch exponential graphs. And also, if you have any questions, please feel free to put it in the comment section, or you can email me directly. And also, if you've not subscribed, please don't forget to subscribe and click notification bell so that when I post the next video, you'll be the first person to know. All right. So I'm going to see you soon in the next video. See you soon.